So I know how everyone's first time is surprisingly very frustrating, and it's not always smooth. I mean, we're not just born walking. We actually have to be born, and then you grow a bit, start crawling, and then walk. And even when you're walking, you start taking baby steps before you start walking. So yeah, it's been a very fun journey for me. I started Java 2 years ago. 6 months ago is when I actually managed to get serious with it. So I've only been learning for like 6 months, but I think I've learned a significant bit in that time. Um, it's a very fun journey when I look back at what happened, and the only reason I have that is because I know I kept that first project when I actually started learning data types. I had to type them down in Notepad because I didn't have an ID. So a Notepad on my phone was where I typed down everything, and I eventually put it into the PC. So it's been a very fun journey for me, and I'd like to think it's a very fun place that we're going. Here is basically my first ever. So this is my oldest project. My first ever Java project is this one right here, and I called it lesson log, so I can actually log down what I've learned. So yeah, this is oh my god. I look back at this and all the mistakes that I mean, there's 13 warnings in here. There's even a weak warning in here somewhere. Oh my god. Now I look back at this and bruh, I've come such a long way. And yeah, most of these warnings are just like unused here. There's this nonsense, which is obviously just redundancy. I mean, we just hard coded that while the number is 12. So if 12, this is automatically true. Boolean want is true, and then is true is true. Oh, wow. Yeah, and want is true is if it is equal to is true. This is so redundant. That's where these errors come from. But a lot of them probably do come from the unused because as you can see, all these lesson names that I actually did are just completely pointless. So if we try to suppress warnings, unused, that's not unused, is it now? Yeah, unused. Am I liking? Okay. We just went from like 13 to 3, so these are just absolutely redundant. But yeah, this kind of isn't what we're here for. Just thought I'd share this because obviously I would log down these lessons. So lesson 1, lesson 2, I can actually call these in a method and actually just absolutely have fun with it. But that's kind of not why we're here. What we are going to be doing is actually learning about the different types of classes that we can make. I don't know if I should call it types of classes because it's not really that. We're going to delete this and we're going to show the different types that you can have on here. So control and space to actually bring up the suggestion thingy. We've got classes. We can put in an enum. Unfortunately, it's not really sorted to the specific type that can be here. We can have an interface, and we can have a record. We can also have an annotation in here. But yeah, let's talk about that. Let's first create a new package. We're gonna call it types. So we're gonna start with the class. Okay, that's probably the most common one, and I'm sure that everyone is pretty much familiar with this. So we can have public class, some class. All right, here we are. And yeah, I'm sure you guys already know how classes work by now. I mean, it's the thing we've been dealing with since day one. What I'm gonna do is I'm gonna declare a method. So public, I'm gonna say void do something. Now imagine you name the class do. Do is a reserved keyword. So if you don't do that, do something. We're just going to declare a public method just like this. Now what classes can do, we're going to go to the main here. What classes can do is they can be, we can create objects from them. So we can say some class is equal to new some class. That makes sense. We now have an object of the some class, right? And something else that we can do, I need to create another class for this. I'm not going to create a new file. I'm going to create another inner class. This one can probably just be a class. So class, inner class. I bet you didn't know you could do this. Okay, let's also make it a static one because
That's what the warning is about. In a class, index right, that wasn't in the class. Now, with methods, with classes, you can extend them. So, if inner class extends some class, then we say that inner class is a subclass of some class, is a subclass of some class, or it's an inheritor of some class. Some class is a superclass of inner class. This is so confusing. I can imagine. So because we extend this some class, we gain access to the methods that exist in this one. So we can come over here and we can control and O to implement, and as you can see, we now have access to this do something method. So just like that, we now have access to this do something method. We've now written this, and it's all fun. Let's move on to the next one, which is going to be an interface. So public interface. Now the difference between this interface and a normal class is, remember how we had a method in the sum class over here? We had this method. Now, whenever you extend the sum class, you did not have to actually use this method. You can go without it. The interface, the methods that exist within an interface, these have to be called when the class has been, has been taken over by the interface. So we can have the same, let's say, do something. I don't know. Should I call it do something? Yeah, I think I should. No, I'm not gonna call it do something. We're just gonna say void do it. Now you could have a method body, but you're going to have to make sure that it's default to tell Java that what you're doing in here is a default. So basically default, and then you can actually add in code for what you want. But if you're not adding default, then you're just telling them that whichever class implements this interface will need to have a doIt method. It also need to have a string name method. I'll forget the parenthesis. Yeah, so you can go here and you extend classes, right? But you implement interfaces. And as you can see, we now have a warning because we need to actually implement those. So it must be the declared abstract or implement method do it in interface. So what's this saying? That if you implement this, if you implement an interface, unlike regular classes where you're extending something, with interfaces you have to implement the methods that are in this one. Every method in an interface is declared abstract by default. Now you cannot have abstract methods inside a non-abstract class. So this is static class. It's not an abstract class. So if we try to create abstract void do me, so abstract methods, like I said, they do not have a body. But you cannot do this because this is an abstract method inside a non-abstract class. So this is a way of actually forcing something to have methods if it's not having abstract methods inside the class. You can only extend one class, right? But you can implement multiple interfaces. So you can implement interface, we can implement list, we can implement list of type Java. I'm not going to do this because you're going to have lots of errors, but you can have you can implement as many interfaces as you want, but you can only extend one. So that's interfaces summed up in a nutshell. Next up, we have a record, and these are absolutely tons of fun. So public record, and this one actually has parentheses like a method does. And what you do in here, you actually place in parameters. So we have string name, and we also have string type. And yeah, that's it. Like, isn't it? You can have as many as you want. Now, what sets this apart from a regular class is that let me just have a constructor in this class here, so I can say public inner class, and then we need to have our own, so we can say string name and then string type. So we can have this, and whenever we declare a new inner class variable, inner class is equal to a new inner class. So now to come up with a name, so name is going to be class. What is the type? This one is an interface. You can also have another one. Just need to change the variable name. So this one is inner class 1. So that's also a class, but this one is actually an enum. So basically this is what you'd have to do, and then you'd have to set up like getter methods for string and the type inside this. So what records bring to the table is you don't have to do any of that. You just say record is equal to a new record, and then you need to pass in the same. So class, and type will be annotation, just like that. And while if you use a regular class to actually store stuff like this, you're going to have to create getter methods, like I said. But with records, you don't even need to set in getter methods. So you can say dot name. What this will do, this will return the name here. It says the result is ignored because we're not actually using this, right? To actually use it, what we do is say SOUT record dot. Let's just get the type because it has more description. Now we have this type. Let's actually run this, and you'll be able to see we actually get annotation on the terminal, assuming we're going to run with it. So that means we get annotation there. But how is that so? We don't have any getter methods. Well, because a record is meant for storage of that sort, these are automatically generated. You don't need to have any of them here. They are automatically there, ready for use. That's why I want to use records instead of regular classes for storage like this, because they're just easier to use. They have inbuilt getter methods. They're just lots of fun. Alright, up next is an enum, and enums are also very fun. So enum, yeah, like that. Now, under normal circumstances, what you want to do, you would like to declare, for example, today's date, or maybe what date today is. So we can say string day is equal to Saturday. Because today actually is Saturday, right there, it's Saturday. And because this is a final one, it is now a constant value, which means we cannot change day to be Wednesday. That's not how they work. We cannot change this. It's literally final, as you can see. So let's say you want to have a value to actually show all of the days of the week. But if you set the parameter, like we've done here, to be a string, then they can type in whatever they want and you will not have any problems, because obviously it's a string, to take in any kind of string. But instead of a string, you want it to actually take in a very specific type. That's where enums come in. So we're going to create a method. I'm going to say public static get day. Public static. Wait, it's gonna return string. Actually, let's just prefer it be void, and then you can say get day. So we're gonna have enum. Let's make sure we collect ours. So enum. So this will only take in a specific type. So if we go into here, we can now set default values. So in a week, we've got Sunday, we've got Monday. I'm just gonna put in Saturday because it's like there's 7 days in a week. You can have as many as you want, really. Just make sure they're separated by commas, with the final one having this. So these are now constant values. And what happens is, because we're requiring an enum here, we're going to actually come here and I say get day enum. I'm gonna have to pass in a value from the enum, so we're going to say enum.sunday. This ensures that you cannot just put in any random string like Saturday. This won't work because it requires an enum in passing a string. This ensures that they cannot just pass in whatever they want. They need to pass in a specified value. So instead of doing that, we just say Saturday. Yeah, now this enum.saturday really does piss me off, so it pisses you off as well. What you can do is say import static net dot encoder dot types dot enum dot asterisk to actually import all, and then you want to get rid of this enum dot part, and then you can just pass in Saturday. You duplicate this, get Monday, and grab Monday. Yeah, as you can see, Monday. So you cannot pass in Saturday. You cannot just pass in a string Saturday. You need to pass in this specific type of enum. And another fun thing that you can do, we're really wasting time here, but I need to teach this. So we can say enum. You can set a constructor. So you can say string and let's actually set it again int day number. So what we've done here, we've actually set a constructor for each and every one of these, and we can say this is day number 1. Monday is day number 2. Saturday, day number 7. Alright, so just like that. Now we can have a private integer day number This can also be finals, since obviously we're dealing with finals in here, so this works. So if we return the main one, you get this, you get day, you get the day, right? So you can get day, and what this will do, I haven't actually done anything here, so I can do, we're gonna say SOUT, I'm gonna print out enum dot get day number. So we're gonna get the day number of the thing that we passed in. So if we run this, we should get 7 and 1 in the terminal. 7 and 2. Wait, isn't it? Oh yeah, Monday is the second day actually. Yeah, so we get 7 and 2 because it's absolutely fine. So enums are absolutely useful when dealing with final values, constant values, and it's very fun because they do prevent user input like that. Very fun. Now the last, but absolutely certainly not least, will be public annotation. Oh wait, we can't do that now, can we now? Public at interface. Annotation and rotation. Annotations are some very wacky stuff. Now, here's an example that I'm sure everybody who's done a bit of Java knows. An example of an annotation, this is an annotation right here. They start with this symbol here, and there's a bunch of them. We are overriding. I can also mark what kind of class can be taken in. So we're going to create ourselves a custom annotation. This is creating a custom annotation. If you didn't know what we were doing, let me not forget to do that. There's not much I know you can do with this. What I do know is you can actually set the retention. We need to use other annotations to create an annotation. Isn't that fun? So I can say,
hello, it's me from editing here, and I just wanted to clarify a bit on retention. And this is basically what decides when our annotations are discarded. We have three types. There's source, which means that the annotation is available in our code as we're coding, but the moment we compile the Java file to a .class file, the annotation is discarded. The second one is class, which means that the annotation makes it to our .class file, but it is discarded the moment we run the program. And the final one is runtime. This one means that the annotation rather, is available throughout our runtime, which means it's going to be there once the program. That's what retention is basically.
Retention policy dot runtime. I always say it runtime because that one just always works for me. And down below that, we can say at target, and now you need to actually pass in the target of what you want. So, do you want this annotation to be for a field? You pass that in, field, comma. Do you want it to be a parameter? You can do that as well. You can do a package as well. You can do parameter, you can do type, annotation type, type parameter. Yeah. So when we say type here, we mean the entire class. So we want our thing to want this annotation to only be used on a field and a parameter. So to go back to the main method here, you will now see that we can go here and specify what type of enum that we want. So we want an enum annotated with this add annotation, right? So we can go back to our enum over here and actually separate these two on separate lines. And when you're using it on fields, you put it on top of the field. So I can say add annotation. And then if you want it for Tuesday as well, you're going to have to say add annotation. So you need to put it on top of the field, and if it's in a parameter, you put it before the parameter type right here. So the cool thing about annotations is, besides just really showing this to actually show that you're overriding a method, you can use these to get specific type of inputs. So maybe you want days that start with W, maybe days that start with T. You can say that at T enum, so only the ones that start with T. And if the user doesn't give you an input that starts with T, then you can throw exception. That's right, we have code that can actually throw exceptions. It's very fun. But yeah, that's probably not gonna be tackled in today's video. But yeah, so this is it, and we only specified that the annotation will only be available for fields and parameters. So if you go ahead and dare go put this on a class, for example, you can say add annotation, it's going to get an error because it's not applicable to type. Yeah, to actually make it applicable to type, you're going to have to go in here, comma, and actually type, and now if you go back to the main, see it has any problems. That is the 5, I want to say types. I don't think they're called types, I just don't know what to call them. But yeah, you can have annotations, enums, interface records, some class right here. Instead of right here where there's class, you can have these 5 different types. And they all have their different uses. They're absolutely fun to use. So yeah, absolutely stunning.